we are going to discuss on analysis and design of a simply supported beam using Staad software. So the problem of simply supported beam is shown here. It's having UDL load and 2-point loads. The total span is 5.5 meters. And the same beam is analyzed using the software Staad V8i. This is the first screen of Staad V8i. And click on the new project. Select the plane frame and give the file name as, take the caps on, simply supported beam. Just give like this and take the length units as meter and force units as kilonewton and click on next and click on add beam and click finish, and you are going to get the initially you will get the grid pattern. So you click on this setup tab of modeling mode just to give the details of the um, job. It is simply supported beam, SS beam. Client I'll type here as GPT, and you give the job number and type the engineer's name and the person who checks this work, and you can make any comments if you want. And once it is done, then you click on geometry. Close this snap node beam window so as to give the nodes. So since it is only a single beam having the length of 5.5 meters, so I'll give the node 1 as a left hand support whose coordinates are 0, 0, 0, and the node 2 is the right hand support which is 5.5 meters, and is the one you can see the two dots here, which means it is node 1 and node 2, and you have to name the node A and node B with the numericals. So I give node A as 1 and node B as 2. So you can see the beam with the two dots means two nodes, node 1 and node 2. You can click on the screen and all the icons will be highlighted. Now you click on view from Z, which is the front view. So you click this one and you will see this, and press on Shift N to see the node numbers here. And now after this one, you click on General tab where you are having the Property tab and Supports tab and Loads tab and Material tab. First you select the Property tab to give the size of the beam. For that you have to click on Define and select the rectangular shape and give the depth of the beam as 0.45 and width as 0.23 and select the material as concrete and click on add, and the same section is added here. Just close it. Now you have to assign this section to the beam. So for that one you have to select this section, rectangular section, and you have to use the assignment method here as use cursor to assign and click on assign, and now you click the beam so that you will see R1 means the reference section 1 is attached to this beam. So once it is attached, you close this one, and now just select the supports. So both ends are simply supported, so you have to create the supports. Click on create. I have to select the pin end So you select the pin end and click on add, and the support S2 is added here, which is a pin support, and the two supports are pin support. So you select the S2 and you have to assign the support to the nodes. So for this one, you have to click on use cursor to assign, click on assign, and click on node 1. So here the one support is attached, and at node 2 click, and the other pin support is attached. So once the two supports are attached, then click on close. Uh, so after the supports, you click on load and definition tab. So here you have to create the loads. So you can uh, see the, you know, the loading pattern here. Over the 3 meters, you're having 35 kilonewton per meter load, and at 3 meters, you're having 20 kilonewton load, and at 15 kilonewtons, you're having you are the load is applied at 4 meters. So here now you shift to the the Staad Pro. Now it's asking to save it. Just save this and click on load cases. So this is some tricky part, and you have to practice it many times to get familiar with the application of loads. So click this one first and click on add. So now you have to create the load case one. Select the loading type as did load and click on add. And this load case one is added here. So close it. Select the load case one and click on add. So now you have to create the loads. So here you see the first one is the self weight. So this load has to be added. So it is the direction is vertical. So it is y-axis and the factor is -1. I told already minus sign indicates the load is acting downwards. So if you don't give the minus sign, the load will be acting upwards. So it plays a very important role. So take it as -1 and click on add. You can see that under the load case one, the self weight is added. Now we have to add the member loads. The first one is UDL load, which is -35, and it is acting over a span of 3 meters. So D2 is 3 meters. It is starting from exactly left hand support. So D1 is 0. So you can see in the figure D1 is 0 and D2 is 3 meters, and the direction is GY, that is global Y, and I click on add. So that will be added. And now the other member load is concentrated port, that is a point load. So the first point load is -20. It is acting at a distance of 3 meters. So D1 is taken as 3. Okay, so GY is the global direction. Click on add. And the other point load is -15. So it is acting at a distance of 4 meters from left hand support. So 4 meters you have to give, and GY is common, and click on add. So all the loads are added here. So now close this window. So all these loads, you have to assign it to the beam. You have to apply onto the beam. That's why you are having question marks. That means it is not assigned. So now you assign all the loads one by one. Click on this load and take the assignment method as use cursor to assign. Click on assign and click on the beam. So entire beam is loaded with self weight. And now click on uniformly distributed load, and you have to click on the beam. So you can see the load is added here. And the next one is the concentrated load. Select it and click on the beam. Anywhere you can click it because it's only single beam. Now you select the second concentrated load and click on the beam. So the second port is applied. So this is the way how you have to apply the loads. So once you apply the loads, all the question marks will disappear and you can see all the green boxes. Okay. So once it is done, just close it and you have to apply the materials. And before that, if you want to see the loads, and you can click on a load icon in the toolbar. So you can see here, and if you want to see the values, you can use a Shift plus V. You can see these values, and you can also see the distance. I mean the span of beam. It is 5.5 meters. So this is the way how you can see this, and use the scroll to make it zoom in and zoom out. Scroll roller in the mouse, and now click on the material because we have given the properties and assigned, and the supports we have created and assigned, and loads also we have defined and assigned. Now the material, already we have assigned the material as concrete, but still you select this concrete and assign to view. Take this assignment option and click on assign and say yes. So we have done all the uh, general tab items. It is the sequence you have to follow. Property. Sometimes you have to give the specifications, and you have to give the supports and loading and material. Once it is done, you have to click on analysis. So in between, it will be asking save. Just say yes and save the file. And now click on analysis and print. And in the perform analysis, you select all option and click on add. So this perform analysis is added here. Close the window. And now go to this analyze menu. In the analyze menu, you are having only run analysis menu item. So you can press this one to run the analysis. So it will save, just save it. And the analysis will run in the background, and it will show all the results. So now you can see there are zero errors and zero warnings. So our analysis part is perfectly okay. So now you can go to this post-processing mode. So click on done. So select this load case and say okay. And this is the simply supported beam. You can see the reactions here, and you can see the reaction at node 1 and reaction at node 2. And you can see the bending moments are free, zero bending moment. You can see the bending moment diagram by clicking this MZ. This is the bending moment diagram. And you can see the shear force diagram. And also you can view the values. Click on these results and view the value. You can see the beam results. Select this one and click on this ends maximum width, and also click on this maximum and these values. You can see and click on annotate, close it, and you can see the maximum bending moment, positive and negative. I mean, it's positive sagging bending moment. You can see this is the maximum shear force. Okay, and this is the way how you have to carry out the analysis. Now we'll go to this, you know, the design part. For that, you have to click on the modeling mode. Okay, so we have completed setup, geometry, general, and analysis and print. Now the last part is the design part. So for this one, you click on design, and in the design you are having timber, concrete, steel, and all. Our beam is RCC, so select this concrete and select the code here, current code, Indian standard 456. It is the concrete code for the design of concrete members. And here you are having three boxes. One is select parameters, define parameters, and commands. So all the three you have to uh, perform. Before that, you have to select the parameters. First one is here, this is select parameters. So click on two greater symbols. So all these will be, all the parameters will come onto the right window, available parameters. Now you can select whatever the parameters is required. I select normally this compressive strength of concrete, and I select the strength of main reinforcement and the yield strength of shear reinforcement. Just hold the control key in the keyboard and click on what are the items or specifications required, and maximum diameter of a reinforcement, main reinforcement and the secondary reinforcement. And also you can select the minimum, sorry, not this one here. It is minimum size required for main reinforcement, and this is for the secondary reinforcement, and select the width of this section. So once you have selected all the parameters which are required by holding the control key, now press on this single greater than symbol. Don't press this double greater than symbol. So if you press this one, all the parameters will come onto the selected parameters. So we just select those and click this one. So only the parameters which you have selected will appear here. Now just say OK. Now click on the define parameters. So you have to define the parameters which you have selected. Click on this one. So it will ask the FC. So it is M25 concrete, I'm assuming. So it is 25,000, and just click on add. And FY, it is 415 steel. So it is uh, the 415,000, and next it is FY for the secondary reinforcement FE 415, add, and maximum reinforcement diameter of the reinforcement is 20 mm. I'll take it as 20, and it is saying add, and maximum secondary is 12, just add it, and minimum diameter of main reinforcement I'll take it as 16, so just add it, and minimum secondary is 8, okay, add it. And width I'm just giving as 0.23, that is width of the beam. Just add it. So once you added all the things, just close it. So now you can see all these parameters are added under the concrete design, but you're seeing all the question marks, which means that this parameter is not assigned to the beam. So you have to carry out this one, and before that you have to click on commands, and you have to select this also, design beam. Add this design beam, and also you have to add this takeoff. Select this one and add it. So since we are doing design of beam, you have to select design commands and take off this one. And if you are doing column design, you have to select the column design. And if you are doing the slab design, you have to do this. And on the other element also, you have to select this design element. So now I have selected design beam as I am designing the simply supported beam. So now close this window, and you can see here all the parameters are listed, even the design beam and concrete take off this one, concrete calculations, quantity calculation. For that you require this concrete take. So now I'm assigning all these parameters to the beam. For this one, you select the parameter FC and click on this assign to view, because this is same throughout this beam. So select this assign to view, click on assign and click on S. So this is assigned, and now you can see the question mark disappeared, and you can see the green tick mark, which means it is assigned. Similarly, assign all these parameters, the FY for main and assign to view. Take the same procedure, and now it is assigned, and FY for secondary reinforcement. It is attached, and the maximum diameter of the main reinforcement, and this is for the secondary reinforcement, and the minimum diameters for the main reinforcement and secondary reinforcement. Take the same method, assign to view, and width is also you have to assign it. And before you are proceeding for the design part, you have to complete this procedure. Then you can go for the design analysis. So here all the parameters are attached and you can see all the tick marks. So this you have to check it once. So once it is done, and the next thing is you have to go to this analyze and run analysis. So this run analysis will be performed to analyze the beam and also design the beam. So click this one. So it will ask to save. Okay, save it. And now you can see the the performing analysis is over, and you can see zero errors and zero warnings. So perfectly, the analysis and design is okay. So now you go to this output file to see the how much is the quantity of concrete and steel reinforcement and all those things along with the analysis part. So for that, you click on this view output file, click on done. So this will be displayed now. You can see the first part, you can see the job name and client name, engineer name, and everything, whatever the inputs you have given here. So now you can see the number of joints and number of members. It is only one beam. Number of supports are two, like that. And you can see the loading patterns, UDL load and concentrated load, two concentrated loads. And you can see the the here you are seeing the movements and reactions. Okay, and after that you can see you click on this concrete design, so it will show you the concrete design. So Indian code and all the parameters what you have given here, and here it mentioned M25 concrete and FE 415 steel, and length is 5.5 meters and size is 0.23 and 0.45 meters and cover is 25 mm. All the parameters mentioned here, and you can see the summary of the reinforcement here. The top reinforcement is having two bars of 16 mm, okay, and the bottom is two bars of 16 mm, and at the center you are having four bars and five bars, okay. So as you are approaching the the ends, the number of bars reduces as the bending moment is zero. So you can see the 8 mm dia two-legged stirrups at the 300 mm center to center. So this is the reinforcement details, and also you can see the volume of concrete. It is zero point 0.6 cubic meter, and the weight of steel is 8 mm bars. This 82 kgs and 16 mm bars, 447 kgs, and the total is 529 kgs. So here it is zero point 0.6 cubic meter. Based on this, you can calculate the number of bags of cement required and the quantity of sand and concrete coarse aggregate required to prepare the concrete. So this way you can calculate the cost of the construction also if you have done for entire building. Frame structure if you take, and if you design using the Staad, you can calculate the quantities of cement, sand, and coarse aggregate, and also the steel quantity also you can calculate. So this is the way how you can design the simply supported beam, and now you can save this analysis and design part. For that, you just click on this print, and it will be saved in PDF format. And there are 6 pages, and click OK. So it will be saved. Just give the file name. So I give the file name here as SS Beam 111 design. I'll give first I'll give analysis and design. Click save. So it is saved. Now close this window. Now you can double click on this beam to see the reinforcement drawing. Double click, and it shows you the length of beam and depth and properties. What is the width and all loading There are three types of loads and shear and bending also you can see, and here they mentioned based on the distance, the shear force and bending moment values. And you can see the deflection also based on the distance. So displacement is zero. And concrete design, you can see here uh, at the center, you're having the 5 bars of 16 mm, and at the top, it is 2 bars of 16 mm. So these the reinforcement details, and here you can see design parameters 415 and M25 concrete, and length and depth and width of the beam. So this is also you can save it. Just click on print and it will be saved in PDF format. And you can give the file name here as uh, you know SS beam and analysis and design. I'll give the extension as reinforcement and details. Click on save. So this diagram is also saved in a template. And now you close this one. So this is the way how you have to carry out the analysis and design of a simply supported beam. So in the uh, you know the manual, I have shown the diagram, and also I've given the procedure. Whatever I've told now, I have given the complete procedure, step-by-step procedure. So you can view the video, and also you can read this procedure and work out on this one. And you can see the maximum and minimum values and all those things. So, and also at the end, I have given the example, the exercises. You can work out on this one, or you can take your textbook and you can work it out. Take any RCC design or analysis of beams, you can take it and work it out. And also, you can take a printout. I've told here you can take a printout of the uh, exercises, that is, whatever the files you have saved, PDF files, you can take a printout and submit as an assignment. Hope you have uh, learned how to do the analysis and design of a simply supported beam. Do more practice and you will get familiar with this kind of beams. Thank you.